New evidence of water on Mars. Insights from NASA's Curiosity rover. The quest to uncover Mars history has long fascinated scientists, and one of the key questions driving exploration is whether the red planet once had liquid water and how long it might have persisted. Mars has shown many geological features that resemble those formed by water on Earth, including river valleys, lake beds, and deltas. NASA's Curiosity rover, which has been investigating Mars since its landing in 2012, has recently discovered compelling new evidence of ancient water systems. This discovery strengthens the idea that Mars might have been habitable in the distant past. Curiosity rover's journey. Climbing Mount Sharp. Since its arrival, Curiosity has focused on the Gale crater and the surrounding areas, particularly Mount Sharp. This 5-kilometer-high mountain, made up of layers of rock, offers a geological history of Mars spanning billions of years. As Curiosity climbs the foothills, it studies different layers of rock, each providing clues to past environmental conditions. Recently, Curiosity has been investigating an intriguing rock formation known as the Marker Band, which has provided the clearest evidence yet of ancient water on Mars. Mars NASA Science. Phys.org. Marker Band Valley. Clear signs of ancient water. The Marker Band stands out because it features rippled rock textures that are remarkably similar to those found in shallow lakes on Earth. These ripples, seen in images from Curiosity's massed camera, suggest that billions of years ago, waves on the surface of a shallow lake stirred up sediment at the bottom, leaving behind the textures. This is the first time such definitive evidence of water waves has been identified on Mars. Phys.org. NASA Science. Curiosity's project scientist, Ashwin Vasavada, noted that the presence of these ripples was unexpected. Previous geological models suggested that this area of Mars should have been drier than other regions. However, the rippled textures suggest that this part of Mars was once home to lakes or other bodies of water, overturning earlier assumptions. NASA Science. Cycles of water, a complex hydrological history. One of the most fascinating aspects of Curiosity's discoveries is the indication that Mars water did not disappear in a simple, gradual process. Instead, the evidence suggests that water came and went in cycles, creating a more dynamic picture of Mars' climate. This is supported by findings such as mud cracks, shallow salty lakes, and evidence of landslides triggered by the presence of water. Curiosity's findings at the Geddes Vallis Ridge, where cataclysmic debris flows are believed to have been caused by water, further support this theory. Phys.org. NASA Science. Mud cracks found in this region offer another piece of the puzzle. These cracks form when wet sediment dries out, leaving behind a pattern of polygons. The presence of these features on Mars suggests that liquid water was intermittently present in the area, enough to cause the sediment to dry and crack. Mars NASA Science. This idea of water cycles adds complexity to our understanding of Mars' past, indicating that water may have been present for longer periods than previously thought. The importance of the Geddes Vallis Ridge. Curiosity's ascent to the Geddes Vallis Ridge has been one of the most challenging parts of the mission. This ridge, which drapes across the slopes of Mount Sharp, holds vital clues about the history of water on Mars. The ridge itself is composed of debris from ancient landslides and debris flows that may have been triggered by water. These materials seem to have come from higher up the mountain and flowed down into the valley. Phys.org. Curiosity's 360-degree panorama of this area, taken with its navigation cameras, shows the dark sands filling part of the channel and a large pile of debris just behind it. Studying this area could offer more information about how water shaped the landscape. The fact that the ridge appears to be part of a single geologic system connected to the channel makes it an even more important focus of research. Phys.org. The Curiosity team is particularly interested in studying the ridge because it provides a clear record of cataclysmic events tied to water. If researchers can better understand how these debris flows were formed, it may offer insights into how water behaved in Mars' past, including whether water was present long enough to support potential life. Why Mars water disappeared. Unanswered questions. While Curiosity's discoveries offer clear evidence of water in the planet's ancient past, the question of why Mars lost its water remains a mystery. There are several theories, one of which involves the planet's atmosphere. Unlike Earth, Mars lacks a global magnetic field. This allowed solar wind to strip away the planet's atmosphere over millions of years, reducing its ability to hold water. With a thinner atmosphere, any water on the surface would have evaporated or frozen, contributing to the cold, dry planet we see today. Phys.org. NASA's MAVEN mission, Mars Atmosphere and Volatile Evolution, has been studying this atmospheric loss, and its data supports the idea that solar wind played a significant role in depleting Mars' water. However, Curiosity's discoveries suggest that water might have persisted in some regions for longer than previously thought. The ripples, mud cracks, and debris flows all point to a planet that experienced periodic phases of liquid water, raising questions about whether the conditions for life may have existed in these periods. Mars NASA Science. Phys.org. Implications for future Mars missions. The evidence of ancient lakes and water cycles on Mars has profound implications for future missions, including those that aim to search for signs of past life. Water is a fundamental ingredient for life as we know it, and the presence of liquid water on Mars in the past raises the possibility that microbial life could have existed there. NASA's upcoming missions, including the Mars Sample Return, which aims to bring samples of Martian soil and rock back to Earth, will play a critical role in investigating this possibility. Mars NASA Science. Curiosity's findings also provide valuable information for future manned missions to Mars. Understanding the planet's geological history, including where water may have been present, can help inform landing site selections and exploration strategies. For example, regions with evidence of past water might be prime locations to search for signs of life or to study Mars' climate history in greater detail. Moreover, knowledge of water's past presence on Mars may eventually help future astronauts extract water for drinking, farming, or creating rocket fuel. Technologies that can process Martian soil or ice to obtain water could become crucial in enabling long-term human exploration and settlement on Mars. The broader picture, Mars as a dynamic planet. Curiosity's discoveries are reshaping our understanding of Mars as a dynamic planet with a much more complex climate history than previously believed. The ripples and other water-related features indicate that, far from being a uniformly dry planet, Mars may have experienced periods of wetness interspersed with drier conditions. This fluctuating climate suggests that Mars was once more Earth-like, with environments that might have been capable of supporting life. Phys.org. NASA Science. The exploration of Mars continues to captivate the scientific community, particularly in its potential to support life, either in the past or possibly in the future. Water is a key element in this search, and NASA's Curiosity rover has recently delivered groundbreaking new evidence that further enhances our understanding of water's role in shaping the Martian landscape. This discovery marks a pivotal moment in our exploration of Mars, providing deeper insights into how the planet's ancient lakes and water cycles might have contributed to conditions favorable for life. Curiosity rover's mission and focus on Mount Sharp. Since landing in the Gale crater in 2012, the Curiosity rover has been systematically studying the geology of Mars, particularly focusing on Mount Sharp. The mountain, which rises from the center of Gale crater, is composed of layers of sedimentary rock, offering a unique window into the planet's past. As Curiosity ascends Mount Sharp, each layer it encounters provides clues to the environmental conditions that existed during different periods of Mars history. One of the most significant recent discoveries occurred in the foothills of Mount Sharp, where Curiosity began exploring a region known as the Marker Band. This thin, dark layer of rock intrigued scientists due to its unusual appearance and the rippled textures found in the sediment, which are reminiscent of those formed by water on Earth. Phys.org. NASA Science. This observation suggests that shallow lakes once existed in this region billions of years ago, with waves on the lake's surface causing the sediment to ripple, just as they do on Earth. The ripples, evidence of ancient lakes on Mars. The rippled rock textures found in the Marker Band are among the clearest evidence yet that liquid water was present on Mars for extended periods. These ripples indicate that water on the Martian surface was not only present but actively moving, creating waves that stirred up sediment at the bottom of the lake. This discovery is crucial because it provides tangible proof of dynamic water systems on Mars, an essential factor when considering the planet's potential to harbor life. The Curiosity rover's mast camera, MastCam, captured detailed images of the ripples, allowing scientists to study their formation. This evidence points to a time when Mars had a much wetter climate than it does today, supporting the idea that liquid water played a significant role in shaping the planet's surface. Phys.org. Such findings are critical in understanding Mars' climate evolution and the processes that led to its current, arid state. Water cycles and the Geddes-Vallis Ridge. One of the most intriguing aspects of Curiosity's discoveries is the evidence of cyclical water presence. Scientists believe that water on Mars didn't just disappear in a straightforward, linear fashion. Instead, it came and went in phases, with periods of drying and re-wetting shaping the landscape. The Geddes-Vallis Ridge is a prime example of this cyclical water activity. This ridge, which is composed of debris from ancient landslides and mudflows, was likely shaped by powerful water flows that carried debris from higher elevations down into the valley below. Phys.org. Curiosity's 360-degree panoramic images of the Geddes-Vallis region show dark sands filling parts of the channel and a large debris pile behind them. These features indicate that water not only shaped the valley, but was also responsible for triggering catastrophic geological events, such as landslides, that contributed to the formation of the landscape we see today. NASA Science. The evidence gathered by Curiosity suggests that Mars' hydrological history is far more complex than previously thought. Instead of a planet that simply dried up as its atmosphere thinned, Mars may have experienced multiple cycles of water activity, with liquid water coming and going over extended periods. This raises new questions about how long liquid water might have persisted on the surface, and whether these conditions could have supported life. Geological evidence of water's influence on Mars. In addition to the ripples and debris flows, Curiosity has found other geological signs that water once played a central role in shaping Mars' landscape. For example, the rover has discovered mud cracks in several regions, which form when wet sediment dries out and contracts, leaving behind polygonal patterns. The presence of these cracks indicates that liquid water was intermittently present in the region, enough to cause the sediment to dry and form these unique shapes. Phys.org. The discovery of shallow, salty lakes in other parts of Gale Crater further supports the idea that water was once widespread on Mars. These lakes likely formed when water collected in low-lying areas, eventually evaporating and leaving behind salty deposits. Such environments could have been habitable for microbial life, raising the tantalizing possibility that life once existed on Mars during its wetter periods. Mars. NASA Science. NASA Science. What happened to Mars water? One of the central mysteries in Mars exploration is why the planet, which once had flowing water, is now a barren, dry world. Several theories attempt to explain this, but the most widely accepted explanation involves Mars' atmosphere. Unlike Earth, Mars lacks a global magnetic field, which means it was vulnerable to the effects of solar wind. Over millions of years, solar wind likely stripped away much of Mars' atmosphere, reducing its ability to retain heat and water. Phys.org. As the atmosphere thinned, Mars became colder, and any surface water would have either evaporated or frozen. However, Curiosity's discoveries suggest that water persisted in some regions for much longer than previously thought, raising questions about the role that underground reservoirs of water or seasonal melting of ice might have played in sustaining liquid water on the surface. NASA Science. The role of MAVEN and other missions. While Curiosity focuses on geological evidence of water, other missions are studying Mars' atmosphere to understand why it lost its water. NASA's MAVEN, Mars Atmosphere and Volatile Evolution mission has been collecting data on how Mars' atmosphere has been eroded by solar wind. This information is crucial in piecing together the timeline of Mars' water loss and determining how long the planet may have remained habitable. Phys.org. The European Space Agency's Trace Gas Orbiter and NASA's Perseverance rover, which landed in 2021, are also contributing to this effort. Perseverance, in particular, is searching for signs of ancient life in Jezero Crater, a region that was once home to a large lake and river delta. Together, These missions are building a comprehensive picture of Mars' climate history and its potential to support life. Implications for future Mars exploration. The discovery of clear evidence for ancient water on Mars has significant implications for future exploration. For one, it highlights the importance of selecting landing sites for future missions, especially those aimed at searching for signs of life. Regions like the Marker Band and Geddes Vallis, which show clear evidence of water activity, are prime candidates for further study. Phys.org. NASA Science.